think we're going. Sounds like we are. We're ready to roll with that. So you can read what it says today's agenda would be, or this video's agenda would be. Obviously, I can't assign you writing during a video, or maybe I could, but I won't. But I do need to assign you a writing piece to deal with what we're doing or what we did yesterday. And we're going to talk in more detail about separable differential equations, like this one. Okay, so this is a differential equation. And when we talk about separable differential equations, what we're looking to do is the same thing, try to figure out what was the original function that we started with, that we ended up with this function as the ultimate differential equation. And so when we're talking about separable things, what we need to do is separate the variables. So we need to separate the variables. So what we'll do is we will first of all get the x, because x is on one side and the other on the other side. So we'll have 3y dy dx equals negative x squared. And then if I just multiply by dx on both sides, I'll end up with 3y dy equals negative x squared dx. And that is something that I can integrate. I integrate this side, I integrate to that side. The integral of 3y is probably 3y squared over 2. And the integral of negative x squared dx is going to be negative x cubed over 3 plus c. And remember, we only add the plus c to one side as we do this, so that, because we don't need to add a constant to both sides. So then the last thing I probably would do is let's try to clear out the fractions. So I might multiply through by 6, perhaps. I multiply through by 6, that'll get rid of the 2's and the 3's. So if I multiply through by 6, I'm going to get 18 over 2. I'm just going to show you what I'm doing. 6 times 3 is 18. 18 over 2 is 9. So I got 9y squared. Multiply through by 6 here. 6 over 3 is 2, so equals negative 2x cubed plus c, and we might even rewrite this as 2x cubed plus 9y squared equals c. And really, probably should call this c1, just because my constant changed as I went through. So we try to keep track when a constant changes, because we've done something that it does actually change. Because if I didn't, then this constant's not the same one all the way through. And the ultimate constant that we end up with is the one we call c, because 6 times a constant is a different number, still a constant. Okay, separate the variables, integrate, try to make it look nice. Try to get it in some form that isn't all crazy looking. Ooh, two things there. Did I go to the right place? Yeah. Okay. So this one, sine x, y prime, equals the cosine of x. So again, what we're going to do is try to separate the variables. I'm going to try to do that. So remember, this is sine x dy dx equals cosine of x. Seems writing poorly. I don't know which. I'm trying to do that. Alright, so sine x dy dx, that's awful, equals cosine of x. So separating the variables, we're going to end up with sine x what am I going to do here? It doesn't make any sense. Let's try this again. If I separate the variables, on this side I'm going to have dy equals cosine x over sine x dx. Guess that's alright. Cosine x over sine x dx. And remember, cosine over sine is cotangent, so dy equals cotangent of x dx. And so when we integrate, we're going to get y on this side equals the antiderivative of cotangent dx plus c. And the antiderivative of cotangent is going to be the negative natural log of sine of u. I think it's the sine of u. Yeah, because this is a u primed over u situation. Negative natural log of the sine of u plus c. So sine is cosine, so it's not going to be negative. Sorry. All right, I totally forgot what that would be, and so we end up with that. So we started with the natural log of the sine of x. and we ended up with an equation that looked like sine x y prime equals cosine x. Separate the variables, move forward. Ooh, a little bit more difficult problem, but we can do it. X y prime equals e to the y plus 1. Or over e, yeah. I'm having a hard time speaking. So let's rewrite that as x dy dx equals 2 times e to the y plus 1, I guess. Separating the variables, how am I going to do this? I think I need to get my y's back on this side, so I might have just multiplied in vain. Let's make this dx over x, 2dx over x, equals dy over e to the y plus 1. Might work. Alright, I'm just thinking out loud here for a second. I may have to pause this thing, but we've got the variables separated. So, let's see. This side, how do I integrate dy e to the y plus 1? Okay. Be right back. Let me think. Okay, well, so whilst we were paused there, I figured out that the antiderivative on this side is it's 2 over x, so it's going to be twice the natural log of x plus c. But this one, and this is what was throwing me off, we don't have a form for that. It doesn't fit one of the forms that we know about. If we were trying to get a u primed over u situation, we'd have e to the, we'd have to have an e to the y on the top. We can't just move this thing up because there's two pieces to it, so we don't have the skills at this point to integrate something like that. So at this point, we got to do with the punt and say no can do. We can't separate we can separate the variables, but we can't integrate the thing that's separate. At least we can't integrate both sides. So it's an excellent adventure in separating the variables, but not so good in doing the integration part. So let's try this one because I'm pretty sure we can handle this one as it stands. So x squared y primed plus 4y primed equals xy. So first thing I would do is I would factor out y primed. X squared plus 4 equals xy. Okay? And then, let's see, this is dy dx, right? So I want the y's to come on this side, and I want the x's to go on the other side. So I'm going to just do a little fancy thing, and I'm going to say dy over y equals x over x squared plus 4 dx. So take a second, pause if you need to get to the right place. dy over y. So I brought this y over here as divided by y. That came over. Remember, this is let's go in red so you realize I've done something else. That's dy over dx. Okay, so the dy stays, and we bring the y over. The x squared over 4, and that goes over, and the dx comes up to the top on the other side. So this is something that we can certainly integrate. And so when we integrate this, the integral of dy over y is the natural log of y. This one, it looks like it could be a u primed over u. We pop a 2 in, take a 2 out, so we get 1/2 the natural log of x squared plus 4. And we do a plus c on that one. And then at this point, let's see, what would we do? We'd say the natural log of y is equal to the natural log of the square root of x squared plus 4 plus c. I have a feeling my c is going to change. And if I do the e to the thing to get rid of the natural log, I do the e to the on this side. This thing turns into, and I don't know why I'm writing in red, but e to the natural log of y is y. And then e to the natural log of all this stuff is just going to be a different constant times the square root of x squared plus 4. Okay, again, e to the, that turns into, remember the story on that one. So we get a constant, which is really poorly done. Penmanship just gets worse and worse every single day. So, separate the variables. Get to something that you can integrate it, solve it. Okay? So what else we have? We have that. We have that. Ooh, that's the homework. Okay. We have that again, and back. Okay? So my apologies on leading you down the path on this one and going to that place where I got stuck, but you know what? I got stuck for the right reasons. I got stuck because I didn't have a form to do this. And integration at this point is all about making something fit the pattern. If it doesn't fit the pattern, we can't work with it. Both of these fit the pattern. U primed over U, U primed over U. We can make it work. We can solve it. All right, then. That's about all. Thanks for watching. Thanks for playing. Thanks for tuning in. If you have questions, please ask. If you have concerns, whatever, we'll be here.